So two vertical plane mirrors are inclined at an angle of 60 degrees with each other. A ray of light traveling horizontally. So we have two plane mirrors that are inclined to each other by an angle of 60. So let's draw this. These diagrams require that, in fact, you give it a proper sketch. So usually you must use a straight edge. If your hand cannot straighten up so well, you need to use a straight edge. So an angle of 60 degrees between two. Please, can you see? Read clearly from the board.
No, a marker is faint.
Okay,
Yes.
let me change it. Okay, so two plane mirrors, okay, inclined to each other by an angle of 60 degrees. It's a sketch. Here, you need not to draw or measure. It's just a sketch. But these two plane mirrors are inclined to each other by an angle of 60 degrees. Then, with each other, a ray of light traveling horizontally is reflected first from one mirror. So the choice is yours. A ray of light traveling horizontally is reflected from one mirror. So we have the mirror 1, M1, and then M2. We have a ray of light traveling horizontally to one of them. I am choosing M1. So the ray is traveling horizontally to M1. So it's reflected first from one mirror and then from the other. So the ray is reflected first by this M2 and also reflected by the other. The resultant deviation. So the question demands the resultant deviation. What is the deviation or the resultant deviation? You see, ray 1, the incident ray to M2 is supposed to go straight. But because of its interaction with the mirror, its path has been deviated. So this becomes the extent of the deviation of the mirror. Of the ray. Then the ray, let me indicate this as 1 and then 2. 2 is supposed to travel straight. But because of its interaction with the mirror, its path is deviated to this. So this is another deviation. So we have deviation 1, we have deviation 2. And the resultant deviation will be the total deviation, which, okay, as a result of the two mirrors. So here, sigma 1 plus sigma 2 must be the resultant deviation. So this travels horizontal to this one. It means this ray 1 is parallel to this. So if this is 60, okay, of course, this will also be 60. And well, maybe let's assume we don't know. But if this is 60, this will also be 60. So when I draw a normal between the incident and then the reflected, this will be 30. You got 90 minus 60. And then this will also be 30. 90 minus angle of incidence equal angle of reflection. So 30, 30, and so automatically this will be 60. Okay. Now, if this is 60, and when I extend the ray 1 line, we have this angle being equal to this angle. Or, okay, I think vertically opposite will do. So this is also 60. If this is 60, once this is, or we can also take it from this direction. If this is 60, this will also be 60. Alternate angles, okay? Alternate, and then if we look at this one, they also form an alternate angle. So if this is 60, then automatically this will also be 60. Right? This sigma, this is also 60. Then this is 60. By vertically opposite angle rule, we have this side also being 60 degrees. So we have sigma 1, okay, sigma 1 being equal to, this is 120, this is also 120. So 120 plus 120 giving us 240 degrees as the resultant deviation. Please, are we fine?
Yes, please.
Okay. Question 2. Please, if you have any question, ask. Okay. Question 2. A plane mirror reflects a pencil of light to form a real image. A pencil of light simply implies that we have a point source of light, a very faint source to form. And listen, we are told that the plane mirror reflects. So it isn't, the issue is not that the image is formed, okay, within the plane mirror, but the plane mirror is reflecting a pencil of light to form a real image. And real images are expected to be formed on a screen, meaning the plane mirror reflects the pencil of light onto a screen and a real image is formed. Now the question is that then the pencil of light incident on the mirror is the pencil of light incident, the pencil, and then the pencil of light incident on the mirror is, what will be the pencil of light incident on the mirror? In fact, once the mirror reflects the pencil of light from the source to form a real image, then the pencil of light must converge, because it must converge. Please, here we are given possible answers. So they are parallel, they are convergent, they are divergent, and then none of the above. We are told that the mirror reflects the light to form a real image. And for a real image to be formed, okay, reflected rays must converge to form a real image. So once the image is real, then it implies that the pencil of light must converge on the mirror. Okay, If the image is virtual, then virtual images are formed as a result of the apparent intersection or the virtual intersection of reflected rays. And so we expect the images to diverge. But here, we are told the image is real. And so it must be converged. Then question 3.
Sadia,
Hello.
please can you repeat what you just said? Like I
Praise
appreciate it.
God, you were not listening. Praise God, this is what I just said.
No, say
Okay, pay attention and listen. The question is that a plane mirror reflects a pencil of light to form a real image. Then, the pencil of light incident on the mirror is, you see, if the pencil of light incident on the mirror is diverged, there is no way a real image can be formed. Okay, so if the reflected, the rays, that incident on the mirror diverges, then we must trace the rays backward to form the image. And this will give us a virtual image. But once we are being told that the mirror reflects the pencil of light to form a real image, then the rays, the pencil of rays or light must converge on the mirror to form that. Priscilla, are you okay?
yes, please.
Then the next question, what should be the angle between two plane mirrors so that whatever be the angle of incidence, the incident ray and the reflected ray from the two mirrors be parallel to each other? I take it again. What should be the angle between two plane mirrors so that whatever be the angle of incidence, the incident ray and the reflected ray from the two mirrors be parallel to each other? So if we think that the distance or the angle between the two mirrors is acute, assuming theta is less than 90, these are the two mirrors. If we assume the angle between them is less than 90, we are looking at incidental light on this, so that this is the incident. The reflected ray produced by this would also be parallel. And you see, over here, the argument is that when rays are parallel, they must have the same slope. So the angle from this, and then the angle from this line to the other one must be the same. And when you draw it this way, in fact, it's very, very difficult to have this angle theta, which is less than 90, and to have the reflected and then the incident ray being parallel. It's very, very, very difficult. It's almost as if this ray is along the interface. which cannot be, because if a ray of light, before it can just be on the interface, then if this is the surface of the mirror, then the ray must just be parallel to the surface for it to go this way. So for theta to be acute and then have this incident and then the reflected rays being parallel, very, very, very difficult. Another argument we can advance is that if the angle is obtuse, greater than 90, is this the mirrors are positioned in such a way that the mirror, okay, the mirrors have this angle, an acute obtuse angle between them. Then we are looking at incidenting a ray hitting this and then be parallel. Now, this is incident, this is reflected. It means that if these two rays are parallel, then this angle must be equal to this angle. Then it also means that, okay, these are not the same, but the basic rule is that two parallel lines have the same slope. These two angles must be the same. So if we are assuming that the incident ray is, angle of incidence is theta, then this must also be theta. Then normal, another normal here. Once this is theta, so this angle is 2 theta. This whole angle is also 2 theta. This is 90 minus theta. This is also 90, 90 minus another theta. And this angle is obtuse. In fact, to get this angle is very, very difficult. If the two rays do not have a precise relationship, to get this acute angle, it means this plus this would have to be equal to 180. Getting the obtuse angle, exact value for it, is very, very difficult if the two mirrors do not have a special relationship. It is difficult to get the obtuse angle for this to work out. Now let's also consider when the two rays are exactly 90 perpendicularly to each other, meaning we are assuming that this and this have this relationship. So an incident ray reflected, this is a reflection from this, but the reflected ray to the second mirror must be directly parallel to this one. So there's a reflection. If we extend the line to get the deviation, this is the angle of deviation. This is also the angle of deviation. Because this ray and this ray are parallel, then it means that the incident ray, okay, and this reflection must make an angle of 90. And so will be this angle as well. this is 90. Then when we draw a normal, 45 here, 45 here. Okay, this angle here becomes, is also 45. Then let's judge it here. If the incident and then the reflected, if we draw a normal, this is also 45, this is 45, and this will also be 45. Now, we have looked at if the mirrors are perpendicularly to each other, so 90, satisfying sum of angles in a triangle. Over here, we had it difficult determining this. Over here, to get that parallel relationship between them is very difficult. Now, if this is 45, assuming the angle of incidence, this is 30. This is 30, this is 30, and so this will be 60, 30, 60, 60. It satisfies it. Okay. Now, if this is 60, this will also be 60. This is 30. Okay. This is also 30. It will satisfy no matter the angle. So with the angle of 90 degrees between the two mirrors, no matter the angle of incidence, you have the total angle around being 180, 180. Meaning that with this special relationship, you can easily determine each of the angle of incidence, angle of reflection, and they will all sum up to be 180 here, 180 here. So the only angle which will satisfy an incident ray being parallel to the reflected ray between two mirrors must be 90. Must be 90 degrees. Please, is that okay?
Yes, please.
There's another way out, but I think later I'll write it and then send it to the platform. The other method. But the last question on the trial. A small object is placed. Let me clear this. A small object is placed 10 centimeter in front of a plane mirror. So please, these questions, most of the time when you sketch it, it gives you a better view than just looking at it and then trying to analyze the problem. So a small object is placed 10 centimeter in front of a plane mirror. So assuming this is the object, from the plane mirror to the object, you are told this is 10 centimeter. If you stand behind the object 30 centimeter from the mirror, if you stand behind the object 30 centimeter from the mirror, so Adoma stands 30 centimeter from the mirror. So if this is 10, then from the object to where you stand must be 20. So this is Charlotte. So from the object to where Charlotte stands is 20, because we are told that she stands 30 centimeter behind 30 centimeter from the mirror. And look at its image. What image is she looking at? A small object is placed 10 centimeter in front of a plane mirror. If you stand behind the object 30 centimeters from the mirror and look at its image, the distance focus for your eye will be. So you are looking at the image of this object. Now, in plane mirrors, object distance equals image distance. So if this is 10, the image would also have a distance of 10 centimeters away from the mirror. So this will also be 10 centimeters. So if you are here and you are looking at its image, okay, if you are there and looking at the image, what will be the distance focused on your eye? Class, yes, what will be if you are here and looking at the image of this, there's the image eye of this object O. What will be the distance focused on your eye?
Mr. Jeffrey, so 40 centimeters.
Exactly, 40. Exactly. So, you see, set questions usually not so difficult, but you must pay attention to the statement and then try to get a picture of how the question looks like. So clearly, the distance will be 40 centimeters. Are we okay? All right, so let's continue from where we ended last time. Formation of images in spherical mirrors. Formation of, we went through the rules. Let's rush through the rules once again. And then, please let me drop attendance, okay? Once the earlier attendance list wasn't so encouraging, it will be, let me just drop.
Mr. Yeah, please, you've muted yourself.
Yes, what I was saying is that the rule, as we went through last time, applies to both concave mirrors and convex mirrors. But usually, when we are discussing the rules, we only refer it to the concave. So I'm going to combine for concave and then convex. How the rules. Please, concave mirror or Quick one.
Divergent.
Concave or
Convergent.
converging. Converging. This mirror converges rays. And convex or diverging. Convex mirror, concave mirror curves, the reflecting surface curves inwardly. And then for convex, the reflecting surface curves outwardly. Okay, so the first rule, let me draw my principal axis. All measurements are taken from the pole. The object is always placed in front of the mirror. All measurements are taken from the pole. So for convex, the pole is here. Then a point where all paraxial rays converge, the principal focus or the focal point. The point where all paraxial rays converge, F. Now a point where rays that incident on the mirror perpendicularly converge after reflection. But in drawing so, you do not forget R is equal to 2F, where R is the radius of curvature, F is the focal length. So if you measure X distance, you measure the same distance from F to C. So this is the center of curvature. We do the same thing for, this is F. We measure the same thing for center of curvature C. So what we are saying is that from the pole to this is the radius of curvature. From the pole to F is the focal length. Now the difference between focal length of this and focal length of this one is that the focal length of convex mirror, so concave mirror or converging, has a real, let me write it in capital letters, has a real principal focus. Principal focus. It is either principal focus or focal point. So for concave mirror, its principal focus is real. For convex mirror, its principal focus. So convex mirror has a virtual principal focus and actually a virtual and a virtual center of curvature. So for convex mirror, the principal focus and the center of curvature are virtual. For concave mirror, the principal focus and the center of curvature are real. Why? This is because for ray diagrams, all objects and points that are formed in front of the mirror, all object images, points formed in front of the mirror are real. All objects images, points that are formed behind the mirror are virtual. Class, are you getting the difference?
Yes.
So I take it again. All objects, image, points formed in front of the mirror are real. So real images are expected to be formed in front of the mirror, whereas all points, images, objects behind the mirror are classified as virtual. So if you look at the principal focus of convex, it is behind the mirror. Center of curvature is behind the mirror, and that makes it F and then C, or virtual. So F focal length will also be virtual. So would be the radius of curvature, because they are all behind the mirror. Any question? Yaba, ask me a question. Yaba, are you there?
Yes, please.
All right, let's look at the rules. The first rule, as we discussed last time, is that if a ray parallel and close to the principal axis, if the ray is parallel and, let me use a straight edge. Else, Crystal, you'll be drawing that for me. Crystal, are you there? So the first rule is that if a ray of light is parallel and close to the principal axis, after reflection, it has to pass through the principal focus. So this is one. Let's apply the first rule also to the convex mirror.
Mr. Dear,
Hello.
please, can you repeat the first? I want to write what you said. I didn't get it.
A ray of light parallel and close to the principal axis, after reflection,
It's a ray of light parallel.
and close to the principal axis. If the ray is parallel and close to the principal axis, after reflection, it has to pass through the principal focus or the focal point. So in applying the rule, you must draw a ray which is parallel to the principal axis. This is the principal axis, this line. Okay, and once the ray is parallel and close to the principal axis, after reflection, the reflected ray would have to pass through the focal points. Two, a ray of light parallel to the principal axis. You see, this one converges rays, parallel rays, and this one also diverges. So if we have, let me draw it for two rays. Two rays that are parallel and close to the principal axis. Inshira Ba and Inshira Apahin. Are you there?
I'm here.
Okay, Mr. Akwayin, where are you? So this one, after reflection, yes, once the ray is spiral and close to the principal axis, after reflection, it has to either converge at the principal focus or pass through. So incident ray, reflected rays. So after reflection, the rays either converge at the principal focus or they pass through. Let me draw it for two rays. Convex mirror diverges, but the diverged or diverted ray always appears to be diverted from a point behind the mirror. And this point is the principal focus.
Sir, please come again.
This one, convex mirror, has diverges rays. It spreads out rays. But the diverted ray or the diverged rays always appear to be diverted from a point behind the mirror. And this point is the principal focus. It's the same principle as this. Once the rays are parallel to the principal axis, the reflected rays would either converge or pass through. This one, it will be diverged, but the diverted ray always appears to be coming from this point, the principal focus. So for one ray incident, this will be diverged, but the diverted ray would appear to be coming from this point, which is the principal focus. What the rule is that, yes, the ray will be diverged, all right, but it will always appear to be diverted from the principal focus. You see, incident hits the mirror, it is spreading it out, but the diverted ray appears to be diverted from this point for ray one. If I should draw another for this one, yes, once the ray hits the mirror, the incident ray will be diverged, will spread out. But the diverted ray appear to be coming from a point behind the mirror. So you always connect the reflected ray, which is diverged, to the principal focus behind the mirror to get this principle right. So this is how the first rule works out for convex. When a power ray hits it, it will diverge it. But the diverted ray appears to be diverted from a point behind the mirror. And that is the principal focus. Class, are we okay?
Yes, please.
Second rule. Let me reduce space. Well, this is P. This is F. So this is the focal length, the same measure for the radius of curvature. So this will also be. So please, if you measure maybe 5 centimeter from P to F, it should be the same distance because R is equal to 2F. So this is P. Objects are always in front of the mirror. Don't forget, this is convex. The reflected parts, the coated parts, okay. So if X centimeter for, if this is P, then this, sorry, F, this will also be for C. Now, in the second principle, we are looking at a ray of light from the principal focus or through. Either the ray is directly from the principal focus or it is coming elsewhere and passing through it. If the ray is either from the principal focus or passing through it after reflection, the reflected ray would have to be parallel to the principal axis. The second rule is the reverse form of this one. So this is rule 2. Is the reverse form of the first one. So a ray from elsewhere yes. If it is appears to be coming from or passing through the principal focus, then after reflection, the reflected ray would have to be parallel to the principal axis. So, because this is virtual, okay, the ray is coming from a source and appears to be passing through this. But this one will reflect. But after reflection, when the ray appears to be passing through F, after reflection, the reflected ray would have to be parallel to the principal axis. Please, there's the principal axis. For understanding's sake, let me extend the principal axis here. But usually for convex mirror, it starts from P. Okay, so this is the line we are calling the principal axis. Now, if the ray is coming from somewhere and appears to be passing through the principal focus, then after reflection, it has to be parallel to the principal axis. Just as this one too is. A ray of light passing through the principal axis. You see this one, because it is real, F is real, rays can actually pass through, okay? And so once the ray is passing through F after reflection, the reflected ray would have to be parallel to the principal axis. Over here, F is virtual, so the ray appears to be passing through F. And if it appears to be passing through F after reflection, the reflected ray would have to be parallel to the principal axis. Please, are you okay?
Yes.
Then the third rule. The pole is always the center. I hope you're also drawing. Straight edge, oh. I go see Adoma.
Mr. Yeah.
Straight edge, oh.
Yes.
Tesla.
I saw this coming.
Eh?
You said I didn't you mention my name.
Okay. So this is F. This is P, F. F, Adoma, you there? Or she didn't show up today. Yeah, but I hope you are drawing it with straight edge.
Yes, please.
Okay. So F is here, P is here, F is here, the same measure, C is also here. A ray of light hitting the mirror at 90 normally reflects along the same path. So the two arrows actually show that once the ray is interacting with the mirror in that manner, 90, it will reflect and pass through a point, and this point is a center of curvature. Okay, so incident, reflection. Now, when the
Sir,
ray,
please come again for that one.
okay, so we have a ray of light come in hitting the mirror at 90, an angle of 90 degrees. So it can be, the ray can be coming from below or above. Let me add this one too. Maybe the ray is coming from up here. This one indicates that coming from below, but it can also come from anywhere. So long as the ray hits the mirror at 90, normally, perpendicularly, okay, incident, reflection. So it incidents and then takes the same path as the reflected ray, and no matter where they are coming from, they all pass through a point on the principal axis. And this point, common point, okay, where they are all passing is the center of curvature. They are all passing through this point because the ray hits the mirror at 90. So that's the condition. It doesn't matter where the ray is coming from. It can come from the north, south, but the condition is that it must incident on the mirror at 90. And if it does so, it will reflect along the same path, and the numerous or number of rays would all either converge or pass through the same point on the principal axis. And this point is what we call as the center of curvature, C. Please, are you
So,
fine?
Miss
Sir,
Adria,
please, I want to write what you're saying, but everything is scattered.
I'm too fast.
Yes.
Lizzie, this is what I'm saying. You see, for this to happen, one, the ray must incident on the mirror normally or perpendicularly. This is the key condition. If this condition prevails, it doesn't matter where the ray is coming from. If you look at the diagram, one of the rays coming from up here above. The other one is coming from below. Just to show that it doesn't matter where the ray will be coming from. So long as it is incidenting on the mirror at 90, okay, they will all reflect along the same path as they came. So incident, forward arrow, reflection, backward arrow. Incident, forward arrow, reflection, backward arrow. And they will all either converge or pass through the same point on the principal axis. So ray 1, ray 2 are hitting the mirror at 90, and they are all passing through the same point on the principal axis. And this point is what we call as the center of curvature. This point where all rays that incidents the mirror normally or perpendicularly pass after reflection is what we call as the center of curvature C.
Mr. Yeah.
Ama.
Please, if you say normally, isn't it the principal axis?
No, normally I mean it's incident on the mirror at an angle of 90, normal, 90.
Okay.
Or normally or perpendicularly. Nanekwe, are you okay?
Yes.
Mr. Yeah.
Ama.
So when it incidents on the mirror at 90 degrees and it will pass along the same path,
Yes,
angle of incidence and reflection will be equal to 0.
exactly.
Right.
Exactly.
Okay.
Because they are just lying on each other or parallel.
Okay.
Me, I'm not able to say parallel. Parallel. Millicent, are you fine?
Yes, please.
Abra, are you here? Abra. Hey, I have true and so. Okay, so let's see how that also applies to convex. So the major condition is that the ray, irrespective of wherever you are coming from, you must hit the mirror at 90. So if the ray hits the mirror at 90, it will appear to be passing through a point on the principal axis. And this one, it appears because this is virtual. This one, it's actually happening. So incident and then reflection. So once it hits the mirror, okay, in this manner, it will reflect along the same path and then appear to pass through a point on the principal axis. And this is the center of curvature. I
So,
hope you are,
Mr. Yeah.
Mr. Amma.
Okay. So please, if they say we should state this rule, we should say like the ray the ray which incidents on the mirror normally or perpendicularly pass through a point along the principal axis called center of curvature and reflect along the same path.
It passes through a point on the principal axis, not around, on the, okay.
On the principal axis.
Along the same path. as the incident ray.
Okay.
But you will not be asked to state. Anyway, examination can be modified differently. But then usually we will use it in ray diagrams, as we'll be looking at right after going through the rules, right?
Okay.
The last one. The last one. 4 strong rules. The last one is that when the ray hits the pole of the mirror, it reflects at the same axis. So the ray from somewhere hits the pole, the center of the mirror, and it has to reflect at the same axis. Here, the question is that this angle must be equal to the angle of reflection from the principal axis. So over here, when you are using this rule, you have to be wary of your angular measurements. Either you measure or you estimate it very well, because it's the same axis. So when the ray hits the pole and this angle is 30 degrees, then this angle must also be 30 degrees. So third and then the fourth rule. The ray is hitting the pole, and this is the pole P. It has to reflect at the same axis. Let me extend this a little bit so we can estimate our angle well. So 4 rules of the game. Are you through?
Yes, please.
Can I flip the camera?
Mr. Dear,
Hello.
and please, can you repeat this one for me, the rule? I want to write the theory parts, so I'll write it.
Which one? The
The
fourth
last
one.
one. Yes, sir.
A ray of light hitting the pole of the mirror. A ray of light hitting the pole of the mirror reflects at the same axis. A ray of light hitting the pole of the mirror reflects at the same axis. Are you okay?
Yes, sir. Thank you very much.
Welcome. So let's see how we are going to use this to draw for a ray diagram and then describe the nature of the image formed. In fact, we are only using maximum two of the rules to form the image of the object and then describe the nature. So these are the tools you will need for the game. So I've given you the tools. So let's pick it for concave. Because for convex, it isn't so troublesome. But concave, for concave mirror, depending on where the object is placed. So the nature of image or images formed in concave mirrors actually depends on the position of the object. Different positions of the object would give you different images. So we are going to pick them one at a time to see how it works. So my mirror, please, you are not advised to draw a mirror with a very wide aperture. Just a small aperture will do. AB is the aperture. There's a pole. Now, to cater for reflections that goes beyond the aperture, rule a vertical line. The vertical line will cater for reflections beyond the aperture of the mirror. So you are not expected to draw a worldwide mirror like this. No. Professionally, this is what we do. So my principal axis. Okay. My principal axis the next important thing, you must indicate the principal focus. The choice is yours. I want to measure a distance of maybe 10 centimeters from the pole. So my principal focal length is 10 centimeters. So I measure 10 centimeters using my ruler. Okay. You can also choose yours. Here, you haven't been given values. So you would have to choose. Well, this is 10 centimeters. If from the pole to F, this is 10, then Charlotte, what will be the distance from F to C? Charlotte.
Yeah.
What will be the distance from F to C? Oh, good afternoon. Please give me, I'm coming in. And up a job home. So, if this is 5, okay, a charity. If this is 5, from F to C must also be 5. I measured 10. Okay, so I have to take the same measurement from F. And this is very, very important, class. When you overlook that, the question would also overlook you. You get this part wrong, it affects your ray diagram. Don't forget, we said that R is equal to 2F. R is the radius of curvature from the pole to C. F is the focal length from pole to F. So if F is equal to 5, then R will be equal to 2 times 5, which is 10. So whatever measurement you take here, twice of it will be from here to here. Class, is that okay?
Yes, please.
And that part, super, super important. Okay. So now, the next bone of contention is where to place the object. The object can be placed anywhere. 1, behind C. 2, at C. 3, between C and F. 4, at F. And 5, between F and the pole. These are the possibilities. Behind C is sometimes also stated as between infinity and C. Infinity is any far distance away from C. So when you place the object even here, once it's not at C, but behind C, it is equal as between infinity and C. Please, are we okay?
Yes, please.
Okay, so let's do it for behind C or between infinity and C. So the object is here. It's an extended object. So this is the head of the object, this is the foot. The foot is always on the principal axis. So I'm going to use the rules. The choice is mine as to which one to use. Any two. A ray of light, the rays must always come from the object. Okay, a ray of light from the object parallel to the principal axis. The ray is parallel to the principal axis. And if the ray is parallel to the principal axis, after reflection, what do you think will happen? If the ray is parallel
to the principal focus.
So if the ray is parallel to the principal axis, let me draw it again. After reflection, the reflected ray must pass through the principal focus. And here you must check to ensure that you are doing the right thing. Okay, my line is not straight. So when you are doing it, you have to check all these. that the ray must be parallel to this. So you have to use your eye to gauge properly. So once the ray is parallel to the principal axis, after reflection, the reflected ray must pass through the principal focus. So rule 1. Okay, for an image to be formed, I repeat, 2 or more reflected rays must converge or appear to converge. I said 2 or more. So we need an additional reflected rays, okay, an additional reflected ray to meet or appear to meet. This is incident. This is its reflection. So we need another ray. Okay. I'm using the rule which says that a ray of light from the object, the rays are always coming from the object. I'm going to use the other rule which says the ray of light from the object passing through F after reflection. What must happen? When the ray is passing through F after reflection, class, what must happen?
It must be parallel to principal.
All right. I hope the rest of you are also seeing the picture. So I'm going to use that. So a ray from the object through F after reflection, the reflected ray must be parallel to the principal axis. And over here, you must check your estimation very well, because you are not measuring, you are just estimating. So I'm carefully doing so that the reflected ray would be parallel to the principal axis. Now look at something. This is the first reflected ray, 1. And there's the second reflected ray. I said for an image to be formed, 2 or more reflected rays must meet or appear to meet. Okay, so these 2 reflected rays, 1 and 2, are meeting at this point over here. So where they meet will be the position of the object. But at this point, where they are meeting will be the head. The foot is always on the principal axis as the object. You should look at the object O. The foot is on the principal axis. And so the foot of this image would also be on the principal axis. But where the reflected rays meet will be the head. So the head indicated by the arrow, and then the foot is on the principal axis. This is the ray diagram for this image. Now let's describe the nature of the image form. The nature of the image. Okay.
I said, yeah.
Hello.
Please, the foot of the object, won't you also reflect? Won't it also be incidented on the mirror?
No. We are just drawing a ray. The foot is always on the principal axis. So where you get the position of the head, you trace it to the mirror, to the principal axis, and you have the foot. That is why we have rays only coming from the head.
Okay.
So let's
I see.
look at the nature of the image formed. Chrysler, what will you say about this image? Look at there's the object, this is the image. Chrysler, what will you say about this image? Just give me one observable feature you are seeing.
Okay, I'm lost.
Huh?
I'm lost for real.
Lost. Okay. Then observe. Yes, Yaba. Yaba, give me one feature of this image formed. What will you say about the image form, Yaba?
The image size is the same as the object size.
Yaba, open your eyes. open, open your anyway. Okay, that's your best view. Yes, Millicent. Millicent, give me one observation. Millie. Roll call. Let me. Adwa Sante. Vina, you are all here. Okay. Adwa.
Yes, please.
The images.
It's inverted.
Yes, we are comparing the image and the object. One, you could see that image is inverted. Two, Elvina. Two. Elvina.
Hey.
Open your eyes and then tell me we are comparing the object to the image. What do you see about the image? Avina doesn't see. Okay.
Hey.
Lizzie, Inshira, Effie. Anyway, okay. Please, if go ahead if you have raised up your hand. Just go ahead.
The image created is smaller than the object.
Yes. So Yaba, the image is smaller than the object. Okay. And if image is smaller than object, technically, you say image is diminished. Image is diminished. Three. Yes.
Sir, please, the image, the position has changed.
So where is the image formed now? So image is formed between C and F. Image is formed between C and F. Alvina, it's a very good observation. Then there is a fourth one. Amma.
Dear, please, I want to ask a question.
Okay.
If they say an image is inverted, and then they say an image is laterally inverted, are they the same thing?
No. Inverted. This is the marker. The black end is up. This end is down. There's the object. if an image of this is formed and is inverted, this is how it goes. It turns upside down. The head is at the foot. The foot is up. This is inversion. Okay.
Okay.
Now, lateral inversion. If the image is like this, the object is like this, and it is laterally inverted, it will be like this. This is lateral inversion. So it was like this. Then something happened and it turned laterally. So they are not the same. Okay.
Okay, sir. Thank you very much.
All right. Amma, your hand was up or is up?
Sir, please. I the characteristics. I think the image is real.
Exactly. And that is the another key point. Okay. Image is real. Why is it real? Amma, why is it real?
Please, it is in front of the mirror.
Yes. One, because it is formed in front of the mirror. Two, because it is formed as a result of the actual intersection of reflected rays. You see, we had two reflected rays meeting at a point to form this. Okay, so the reflected rays actually converge at a point to form the image. Okay. Let's hey, I'm again.
No, I want to ask a question.
Okay.
Mr. Jua, if they say the image is formed on the same side as the object, what do they mean?
And it's meaning it's also a real image. Look at it. There's the front side. The object is at the front side, and the image is also at the front side of the mirror.
Oh, okay.
So that's what they mean if it is at the same side as the object.
Okay.
Let's place the object at C, the center of curvature. And I want to clean the first ray diagram. Okay, let me get a different place. So a mirror with a very small aperture. A vertical line, there's a center of the mirror, P, the pole. A vertical line to cater for reflections that goes beyond the aperture. The principal axis. Please don't be an observer. Be a participant and then try drawing too. As for convex, we don't have problem. One or two, you realize that, oh, as for convex, it's not so troublesome. So if this is F, I need to estimate the same distance for C. Object is at C. In fact, with the first one, any of the two rules, I gave you 4, but any two would work. Any two of them. Okay. So I'm also going to use the same thing. Any two. A ray of light parallel to the principal axis after reflection will pass through the center. Sorry, the principal focus. A ray of light through F. The reflected ray would have to be parallel to the principal axis. You see, something is wrong because where the ray is being formed, the two rays are intersecting. That is not how I want it. So I'm going to trace again. Maybe I didn't get my parallel line so well. So if the ray passes through the principal focus after reflection, the reflected ray must be parallel to the principal axis. And here you must be careful, especially if you are using a blank space, as I'm doing. There are no rules or grid lines. Now, a ray of light okay. Parallel to the principal axis after reflection must pass through F. F is here. This is even worse. The problem with this is that, you see, you must check your measurements well. You must check your measurements so well. I only estimated F. Let me measure to get it right. So maybe 10 centimeters from the pole. So 10. Because if you estimate, it can worry you. And then another 10 centimeters to C. Okay, so 10 is also here. So it means my C must be here. Let me change the marker. These are the precautions involved. Because when you place the object at C, the image must also be formed at C. And so you need to get that right.
Mr. Dear,
Hello.
please, the second drawing, I'm lost.
Oh, I'll go through. We are placing the object at C. So this is F. F is here. And the object is placed at the center of curvature. So use ray diagram to describe the nature of the image. Okay, over here, I need to be sure that the horizontal ray is actually parallel to the principal axis. So I imagine well, because there are no grid lines, I must imagine so well. So a ray of light parallel to the principal axis after reflection must pass through F. So I have one reflection. So a ray of light from the object passing through F after reflection the reflected ray must be parallel to the principal axis. So I check my line to be sure what I'm going to draw is actually, and look at it. Even though I didn't get the exact spot, but I'm close to. There's the point. Oh, my markers are not helping. So this is the point where the two reflected rays are meeting. And that should be the position of the image. Let me approximate it to where the object is. The rule is that when you place an object at C, the image must also be formed at C. Okay, but to get that right, you need to take this measurement seriously. R is equal to 2F. Then your parallel lines must be traced, must be ensured that it is so parallel to the principal axis, else you miss the spot. So let's describe the nature of the image formed here. One, what are the characteristics of the image? One, image is Lynette. Hey. Okay, Effie, Afarwa, Nanekia. Ishra. Ishraba, give me one. Effie. Easy, go ahead.
The image is inverted.
Image is inverted, obvious. So image is inverted. Two. Nanekia.
Say their image, no, objects distance from the image puts the image distance from the image.
Nanekia, I can't hear you. Speak up. Nanekia, come again.
The distance from the object to the mirror is equal to the distance from the image to the mirror.
Exactly. And technically, this is said to be image is located at the same position as the object. Image is formed at the same position as the object. So Nanepia, if the image position is the same as the object, then certainly this distance would also work out. Okay. 3.
Yes.
3. Oh, characteristics of the image formed. 3.
State, yeah, please. The image is full.
I'm coming in. Yes, image is real. Image is real. So image is inverted. Image is formed at the same position as the object. And lastly, Ama,
Sir, please, image is of the same length as the object.
the same, I think that's the second point we talked about. The fourth point is that image size is the same as the object size. Image.
Mr. Agent, that's what I said.
Oh, okay. Image size is same as object size. Okay. I want to give you one position. Do it right away and then let's discuss.
Mr. Avia,
Hello.
please, what is the difference between like, oh, okay,
Yeah, okay.
yes,
Okay. So this time your object is between C and F. So using ray diagram, okay, describe the nature of the image form if object is between C and F. Using ray diagram, describe the nature of the image formed if one object is between C and F. So 5 minutes. Your time starts now. Okay, maximum 7. So what did you get? Let me have what and what you had as the characteristics. Yes, image formed is what? Or okay, let's draw it first. So image is between, sorry, object is between C and F. Our F is still here. This is C. And so object is placed between. So a ray of light this will reflect and pass through the principal focus. Two, I can also apply this one, a ray from the object hitting the pole. But over here, you need to be careful with the angle. If you are not able to get the angle right, look at the angle it makes with the principal axis. So you must estimate well. The reason for which I don't often use this rule. So if this is x, this must also be x. So if it hits the pole, it must reflect at the same axis. Okay. So this is where the rays are intersecting. The reflected rays. So incident. These are the reflected rays. And they are all intersecting here. This is the image formed. So by this, the conclusion you could draw from this ray diagram is that one image is, yes, image is one. Help me quick. Image form is.
We said, yeah.
Mm-hmm.
These are questions.
Okay.
We said, yeah. With all the ray diagrams we've drawn, the ray either passes through the focal point or hits the mirror. Like I
Yeah.
said, the image you've drawn here, no ray passes through the focal point.
I didn't use that rule. We have 4 rules and you are free to use any 2. So I used a ray parallel to the principal axis, but after reflection going through F. I could have used the ray passing through F after reflection being parallel, but I felt let me vary the rules. Okay. I just vary the rules and use the other one. But you have to use any other 2.
So say if we also use the rule that says the ray passes through the focal point, we'll still get the same result.
You get the same characteristics.
Okay.
So let's describe the image form here. Image is let's hurry up. It's real. So real 2. Image is two.
It's
Anybody
in between
can.
C and affinity.
Yes, in between C and infinity, or behind. Image is formed between C and infinity. Is infinity sign. 3.
Image is inverted.
Image is inverted. 4.
Image is bigger than object size.
And the technical word is that image is magnified. The image is magnified. So image is magnified. So that's it. Okay. Assignment. Your assignment is that using ray diagram, describe the nature of the image formed when object 1 is placed at F. Then 2 is placed between F and P, the pole. So these are your 2 assignments. Using ray diagrams, so I expect to see this. Okay, for we are looking at concave. So you are drawing a ray diagram too. You have to describe the nature of the image formed. When the object is 1 placed at F, the focal principal focus, and 2 is placed between the F and P. This is your assignment. If you have any question, ask. Priscilla.
Mr. Adria, please, I wanted to ask, so can you use just one rule for everything? Like, if you understand the first one,
Oh,
can you use the one?
there is a situation where no, you can't use one. Oh, you are always using 2. 2 rays must converge or appear to converge. So you are at every instant using 2. You can't use 1. Is that okay?
Yes, please. Yes,
Yeah.
please. So, Mr. Adria, so those the first one, the one of the reflected ray pass through the focal point. Can we use that one like for everything? Those 2 rules.
Oh, you can.
Because the second one, I don't understand.
Okay. What I'll do is so use the 2 parallel and after reflection going through this, going through F, and then from the object passing through F and going parallel. I'll explain the other rules well to you on Monday, okay?
Okay.
But for my work, use the 2 to do it, and then I take you through how to use these ones better. The other 2 rules as well, okay?
Mr. Adria, please, which 2?
I think she's conversant with when the ray is parallel to the principal axis after reflection going through F. And so if this is F, she's comfortable with this, and then it's also comfortable with when the ray passes through F after reflection being parallel to the principal axis. So 1 and then 2. Priscilla, is that not the case?
Yes, please.
Yeah,
I'm
she's comfortable with these 2. So she's finding it difficult to apply when it is hitting the pole. How so? Use these 2 for the work. Okay, on Monday, we'll look at how to fine-tune the other rules usage well, and then pick it with convex mirrors. Okay. All right, so this is where I draw the curtains on today's meeting. In fact, bye-bye and take care of yourselves.